This is chapter 3, titled Data Modeling Using the Entity Relationship or ER Model. So in this chapter, we'll take a look at how a database design process works. Then we'll see an example of a database application company. And then we'll learn about some ER model concepts which are given here. Finally, we'll learn about how ER diagrams are represented using specific notations. And then we'll create an ER diagram for the previously mentioned company. And finally, we'll also briefly gloss over some alternative notations. Okay. So let's begin the chapter by taking a look at the database design process. So this involves two types of activities. The first is a database design and the other is application design. So our focus is going to be on database design. So to design a conceptual schema for a database application. And application design focuses on programs and interfaces that access the database. Generally, this is considered as part of software engineering. Okay, so this is basically an overview of database design process. So let's take a look at it. So first up, we have the mini world. So the mini world, if you remember, is a representation, some form of a representation of the real world. So the next phase is requirement analysis, requirement collection and analysis. So here database designers basically interview prospective users. So prospective user means people that are actually going to use the system. So after interviewing them, they get specific data requirements. At the same time, they also get user required operations or transactions. So this can be retrieval or update queries. And this part falls under functional requirements. Okay. So after you have your data requirements done, we have to get to the next stage, which is the conceptual design. So in the conceptual design, what you do is you define the entity types, relationships, constraints, etc. So it is important to know that this section or this part, this stage of the process does not include implementation details. Okay, so by defining these entity types, relationships, constraints, etc., you have what is known as the conceptual schema. Okay, so afterwards we have the logical design or data model mapping phase. So this process, in this stage, the actual implementation is done. So a database may actually be implemented. I mean, the schema that was previously designed may actually be implemented on a commercial DBMS using, suppose, the relational or object relational model. Okay, so that is the logical design phase. And then we have so with that implementation, you have the logical schema here of a specific DBMS. So that depends on what type of DBMS you are using. And finally here we have the physical design. So in the physical design, you specify things such as internal storage structures, file organizations, access paths, etc. All things related to do with how data is actually stored in the database and retrieved. And from there you have the internal schema. So in parallel, while you are doing this sort of things, applications are also designed, and at the same time implemented as database transactions corresponding to the high level transaction specifications that were given here. Okay, so this was basically an overview of the database design process. Okay, so given here is a requirement of a company database, so we'll take a look at it later after we have familiarized ourselves with ER model concepts. So let's do that. First up, we have entities and attributes. So entities are specific objects or things in the mini world that are represented in the database. So an example of an entity could be an employee. Suppose the employee John Smith, who works in the research department. So department here is another entity, or a project could be an entity as well. And then we have attributes. So attributes are properties used to describe an entity. So an example of an attribute for an employee would be name, SSN, address, sex, birth date, etc. So these are the attributes typically an employee entity can have. Furthermore, a specific entity will have a value for each of its attributes. So the previously defined attributes could also have values in them. For example, the name of an employee could be John Smith, his SSN, which stands for social security number, which is basically, you can think of it as the equivalent of NID, is 1 2 3 4 5 6 7 8 9. His address is this, his sex is M, birth date this, and so on. So furthermore, each attribute has a value set or data type associated with it. So an example could be integer, string, subrange, enumerated type, etc. For example, the name John Smith here is of type string. Okay, then we have types of attributes. So attributes can be further broken down into three types. First up, we have simple attributes. So simple attributes are those that have atomic values inside the attributes. It means they can take exactly one value. For example, an employee can have just one social security number, or an employee can have just one gender. Then we have composite attributes. So composite attributes are those that are composed of several components. So for example, you have address here. So address is an attribute of employee. So you had previously employee here, and address is suppose one of the attributes. So name could have been an attribute as well, but here I'm saying that address is a composite attribute. So composite attribute means that address can have several other components as well, such as apartment number, house number, street, city, etc. So your address here can be, say, further broken down into apartment number, house number, etc. Similarly, name could follow a similar trend, where name could further be broken down into first name, middle name, last name, etc. Not etc, basically these three components. So compositions may form a hierarchy where some components are themselves composite. So what it's saying here is that the components, so this is basically a component of a composite attribute, right? So these components can further be composite themselves. For example, street was a component of the composite attribute address. So what it's saying is that street, which is a component, can be composite as well, in the sense that you can break down street into, so let me get rid of this line, you can break down street into, suppose, street number and the actual name of the street. Okay, so this was composite attributes. Then we have multi-valued attributes. So an entity may have multiple values for that attribute. So an example is color of a car. Suppose a car may have multiple colors. Or suppose previous degrees of a student. Suppose a PhD student may have a bachelor's degree as well as a master's degree, right? So for a PhD student, this previous degree attribute could contain multiple values, whereas if it contained just one value, it would have been called a simple attribute. So an simple attribute is one that contains only atomic values. Furthermore, composite and multi-valued attributes may be arbitrarily nested to any number of levels, although this is rare. So an example is previous degree of a student. It's a composite multi-valued attribute denoted by something like this, previous degree. So basically what it's saying is that, and another important thing that I should mention is that when you have a multi-valued attribute, you use curly braces. Okay, so what it's saying is that composite and multi-valued attributes may be nested arbitrarily to any number of levels. So for example, previous degree is a what? I'm saying it's a multi-valued attribute. That is, it can contain multiple values. But at the same time, this previous degree, which I'm saying is a multi-valued attribute, can be composite in the sense that you can break down previous degree into college, year, degree, field. So that is what it's saying, that composite and multi-valued attributes may be nested arbitrarily. And each has 4 subcomponent attributes. So previous degrees subcomponent attributes are the ones that I've just underlined. So this is an example of a composite attribute that has composite components. So here the attribute is address, which is composite. It has the following 4 components, and one of the components, which is street address, can be further broken down into 3 other components. So this is a composite attribute with composite, with one of its components being composite. Okay, so next up we have entity types and key attributes. So entities with the same basic attributes are grouped or typed into an entity type. For example, the type employee and project. Then an attribute of an entity type for which each entity must have a unique value is called a key attribute of this entity type. An example is SSN of employee. So basically what it's trying to say is that if your entity, whatever it may be, it could be employee, department, project, these entities will have attributes, right? So the attribute that it's unique, suppose the value for an attribute that is always going to be unique is called the key attribute. For example, for the case of employee, it is SSN. So SSN, which stands for social security number, is unique for each employee. Suppose just like your NID is a unique number that's just applicable for you. Similarly, a department may have a unique ID, or a project may have a unique ID, and so on. So these attributes are known as key attributes, the ones that have unique values. So furthermore, a key attribute may be composite as well. So an example would be vehicle tag number, or you can think of it as license plate number. So in a license plate number, basically every car has a unique license plate number, right? However, your license plate number consists of what? The name of the state, or in our case division, and the license plate number. So suppose an arbitrarily example could be Dhaka, 0 1 0, something like this. So in that way your key attributes can be composite as well. So an entity type may have more than one key. So it is also possible that an entity will have more than one key. So for example, car. So car could have a key attribute which is vehicle identification number, popularly called VIN or VIN, and another which is vehicle tag number, also known as the license plate number. So a single car may have these two attributes, both of which contain values unique to that particular car entity instance. And whenever you have a key attribute, it should always be underlined. So since license plate number is a key attribute, it should be underlined. Okay, so displaying an entity type. So here we have the notations. So how in ER diagrams or entity relationship diagrams, entity type is displayed in a rectangular box. In other words, if you have an entity such as employee, you should display it in a rectangular box. And another thing to note here is that you should always write the name of an entity in uppercase letters. And what about attributes? So attributes are displayed in ovals. So suppose if an employee has an attribute name, it should be displayed as an oval. If an entity has another attribute SSN, which is a key attribute, you should underline it. Okay, so what about composite attributes? So components of a composite attribute are connected to the oval representing the composite attribute. So for example, if an entity has a composite attribute street, could further break it down to suppose street number and street name, like this. And as I already mentioned, each key attribute is underlined. Now what about multi-valued attributes? So multi-valued attributes are displayed in ovals. So suppose for the case of an employee, suppose if he has two phone numbers, this attribute is a multi-valued attribute. It should be displayed in double ovals. So this is how you represent entities and the three different types of attributes in an ER diagram. So an example has been given here. As you can see, car is an entity and therefore we are representing it in a rectangular box. Furthermore, since car is an entity, as I mentioned previously, I have written the word car in uppercase. Then we have simple attributes here, make, model, year, and then we have a key attribute here which is vehicle ID. So this key attribute is simple like this other attributes as well. The only difference is that it is a key attribute, and if you remember, key attributes are ones that have unique values. So here we have a composite attribute. Since registration number can further be broken down into state and number, so again this composite attribute here is a key attribute as well. In other words, it has a unique value. And then here a car can have multiple colors, therefore this is in double oval, which means this is a multi-valued attribute. Okay, so an example of car entity has been given here. So as you can see, if you were to fill the information of this specific description that you've modeled, suppose for the case of color is multi-valued, right? So for a single instance of car, you could have more than one color. So here I have red and black, here I have blue. So if you have a multi-valued attribute, it does not necessarily mean you'll always have more than one value. So here, as you can see, I have exactly one value, and then again for color I have two values here. And then let's take a look at a composite attribute, registration. So for registration, as you can see, the state is Texas and the number is ABC123, again state New York, number ABC123, and so on. So registration, as I mentioned previously, is a key attribute, which means it has to have unique values, right? So key attributes, when they are composite, cannot be unique only based on the specific components. So as you can see, ABC, or in other words, the number is common between both these instances. However, when you account for state with the number, the registration overall becomes unique. So these are some simple attributes. Suppose here we have the year, here we have the make, model, and all the other attributes. So entity set, each entity type will have a collection of entities stored in the database called the entity set. So this is basically an entity set that you saw here. So previous slide showed 3 car entity instances in the entity set for car. Same name car used to refer both the entity type and the entity set. So for the entity type and the entity set, you're using the same name, which is car. So entity set is the current state of the data, current state of the entities of that type that are stored in the database. So in other words, entity set is basically your database state for the car entity. Okay, so now in the first few slides we had a few requirements given that we skipped over. So now, based on the concepts that you've learned of entities and attributes, let's try to create a model from the requirements given. Okay. So here we need to create a database schema design based on the following requirements of the company database. So let's read the requirements, and you should try to highlight anything that seems of importance to you. So first up, it's saying that the company is organized into departments. Okay, so department. Okay, so let's read the next line. Each department has a name, number, and an employee who manages the department. We keep track of the start date of the department manager. A department may have several locations. So clearly this means department must be what? An entity. So let's create a model. So department is an entity here. And what are its attributes? So first up we have name, then we have number, so department number, and you should definitely not write hashtag like this. You should always write number or department number. Then we have an employee who manages the department, so let's just write manager in short. Then we have start date of the department manager, so start date of department manager. And finally, a department may have several locations. So a department may have several locations. So from this you should be able to understand that location is a multi-valued attribute, since if a department can have several locations, this location attribute can contain more than one value. Okay, so based on the first requirement, this is the design we've been able to make. Okay, so let's read the next requirement. Each department controls a number of projects. Each project has a unique name, unique number, and is located at a single location. Okay, so from this you can see that project is being further described by name, number, and location, which means project must be an attribute. So let's create an attribute called project. So first up we have each department controls a number of projects. So just like a manager was managing the department, a department manages, or basically actually controls, a number of projects. So there must be a controlling department who controls a specific project. Okay, so a project must have a unique name. So since it's saying unique, definitely this must be a key attribute, since we've already learned that key attributes contain unique values. Next we have each project has a unique name and number. So since number is unique, it must as well be a key attribute and is located at a single location. So here location is single, so that means it must be a single attribute and not a multi-valued attribute like previously. Okay, so let's read the next requirement, which says we store each employee's social security number, address, salary, sex and birth date. So here, as you can see clearly, employee is being described by some specific attributes. So employee must be an entity. So let's create an employee entity, and as you can see, it has the attributes social security number, address, salary, sex and birth date. Furthermore, each employee works for one department but may work on several projects. So this means each employee works on a department. So we must also keep note of that information. However, each employee works on several projects. So that means each employee can work on more than one project. So again, you should be able to denote that this means project must be a multi-valued attribute, since each employee can be working on more than one project. Furthermore, we keep track of the number of hours per week that an employee currently works on each project. So this means, suppose if an employee works on two different projects, suppose project 1 and project 2, you have to be able to keep track of how many hours that employee has worked for that specific project. Suppose in project 1 for the first week he worked 7 hours, and for project 2 in the first week he worked 17 hours. So you have to be able to keep track of that as well. So how would you do that? Well, the way to do it would be to further break down project into, suppose say, name and hours. So here we have a multi-valued attribute project which can be broken down into components, name and hours. So this is like the example that we saw earlier with the degree. Okay, so here we have, as you can see, previous degree of a student was being denoted like this. So a student could have multiple degrees, but each of those degrees could have components such as college, year, degree, field, etc. Okay, so let's keep working on creating the design from the requirements. So we have project, name and hours. Okay, so we also keep track of the direct supervisor of each employee. So each employee must also have a supervisor, and we have to keep track of that as well. So let's keep supervisor as an attribute as well. So finally we have dependent. So each employee may have a number of dependents. So dependents are those who depend on an employee. Suppose it could be an employee's children, wife, etc. So for each dependent, we keep track of their name, sex, birth date and relationship to the employee. So again, this means dependent is a entity, since it's being further described by attributes. So we have name as an attribute for dependent. We also have sex, we have birth date, and we have relationship to the employee. So this could be like son, daughter, wife, etc. So with that, based on the concepts that we've learned, we've created our first design. So if we here, as you can see, the very same thing has been done here as well. But one important thing to note here is that suppose in the case of name, it was not mentioned that name would further be broken down into first name, middle name, last name. So you can skip something like that. And again, entity must always have a key attribute. So even though it was not said that department has a unique name and number, you must always assume that an entity will always have a unique attribute. Therefore, based on common sense, suppose you can give number, assign number as a key attribute and underline it. So for the case of employee, since from common sense we can tell that SSN is always unique, so you can also underline SSN. And in the case of dependent, it's a bit different, since as you can see in the diagram given in the slides, there is no underlined attribute. So we'll talk about this later. This is actually a different type of entity that we'll later learn when we take a look at relationships. And that is basically the next topic we'll discuss in the next lecture.